Related rates, 4.2. Okay, so first review of implicit differentiation. So when we do related rates, we're taking the derivative implicitly with respect to time ddt. Okay, so we've got to do implicit differentiation on all the variables. Now, just to give you a little refresher, for implicit differentiation, because I know it's been a while. To define dy dt, I need to take the derivative of y with respect to t. Okay, so that's the dy dt. Whenever x equals 3 and dx dt is equal to 2. So we're going to find exactly what dy dt equals. It'll be a number. Okay, so I'm going to take this function here, and I'm going to take the derivative implicitly with respect to t. So the derivative of y with respect to t is dy dt. And the derivative of 2x squared with respect to t, well, I'm going to pull the 2 out front, okay? Now I'm going to treat this x squared as a chain rule since x and t are different variables, okay? So remember, if I have something squared, to take the derivative of that, it becomes 2 times something raised to the 1. I subtract 1 from the exponent, and then I take the derivative with respect to t of the something inside there. Okay? That something inside happens to be x. Okay? So this becomes 2x raised to the 1 times the derivative of x with respect to t, okay, which is dx dt. And now I want to take the derivative of minus 6x with respect to t. So the negative 6 comes out front, and the derivative of x with respect to t is dx dt. Okay? So I've got my derivative now. I'm going to plug in x equal to 3. Everywhere I see an x, I'm going to put a 3. So I've got 2 times 2, and then I replace x with 3, and then multiply by dx dt. I know dx dt is equal to 2, so I'm going to put a 2 in here for that. And then I'm going to put minus 6 times dx dt again, which is another 2. And so when I compute this, I get 2 times 2 times 3 times 2, which happens to be 24, minus 12, which gets me 12. So dy dt is equal to 12. Okay? So this is the basic idea here of related rates. We take some equation, we figure out how x and y are related through an equation, and then we take the derivative of that equation implicitly with respect to time, t for time. Okay? And then we might be given some particular information about the problem at certain points. Once we have the derivative, we plug in those values, and then we're able to find what we were looking for in the first place. Okay, let's try another one. All right, so I want to take the derivative of y equals to pi sine x times cosine x. Since this is a product, I need to find use the product rule. So I want to find dx dt whenever x equals pi over 6 and dy dt equals pi. Okay? So the product rule here is applied. So dt of y is dy dt. And then what I'm going to do is I'm going to do the first times the derivative of the second. So the derivative, we've got to think about this. We're taking the derivative with respect to t of cosine of x. Now, x and t are not the same variable, so I need to treat x as a blob, okay? And so the derivative of cosine of some stuff is negative sine of that stuff multiplied by the derivative with respect to t of that stuff, okay? Now the stuff is just x, so that's dx dt. And so let's plug that in here. We get what? We get the negative sine of the stuff, which is x, times the derivative of the stuff, dx dt. Now plus the second, cosine x, times the derivative of the first. Well, the derivative of sine x is cosine of x, and then I have that pi constant out front, multiplied by the derivative of the stuff, which is dx dt. Okay, so now I have my derivative here. I'm going to plug in my x values. So everywhere I see an x, I'm going to plug in pi over 6. And everywhere I see a dy dt, I'm going to plug in a pi. Okay? So let's do that. So I plug in pi here, I get pi there. And so I have pi. Now the sine of pi over 6 is 1/2. And then the negative sign of pi over 6 is negative 1/2. dx dt is what I'm looking for, so I'm just going to write dx dt. And then plus cosine, the cosine of pi over 6, if I plug in x for pi over 6, that gets me square root 3 over 2. And then pi times square root 3 over 2. And then dx dt, once again, I just write it because that's what I'm trying to solve for. So I see that I've got a dx dt and a dx dt here. Okay, so I need to do some simplification here. I'm going to divide everything through by pi. That way I get rid of my pi's. And so when I divide everything through by pi, this becomes 1, right? So 1 equals what? Well, what do I have left? I have 1/2 times negative 1/2, which is negative 1/4, dx dt. And then square root 3 over 2, square root 3 over 2, that's square root 3 times square root 3 is 3. And then 2 times 2 is 4, so that's 3/4 dx dt for the second part. Now, I've got 3/4 and negative 1/4, that makes a half. So 1/2 dx dt. And so I need to solve this. 1 equals 1/2. If I multiply both sides by 2, I get 2 equals dx dt, which is my desired solution right there. So this video is more just to get you ready for related rates. The hard part of related rates is setting up the problem, and then after that, it's just taking derivatives implicitly with respect to t. Okay?